In these videos, I'm trying to get to the really core ideas and not talk around them and the history of them and observations, which we'll leave to in class. But in the case of Faraday's law, I kind of felt like I really needed to talk a little bit about the observations before we went on to things. So I'm going to split Faraday's law up into 3 short videos. The first one is observations. Now, Faraday, who was a scientist back in the 1800s, so almost 200 years ago, now he was a really smart guy. Now, this dude discovered induction. He discovered that if you moved a wire in a magnetic field, you could get a current or a voltage induced in that wire. There was another guy called Joseph Henry who was also working on the same stuff at the same time, and he made some of the same observations that Faraday did. Unlucky for Henry, he missed out on having a law named after him. Just now a summary of some of the observations that Faraday and Henry made about how you could induce a current in a wire and what influenced the size of that current. So here is a loop of wire, and we're going to put a magnet next to that loop or above that loop. So there's our little magnet, and we're going to allow this magnet to move in the vicinity of that loop. Now, Faraday and Henry noticed that if you move the magnet towards or away from the loop, then you get a current induced in this loop. So you get a current induced if you have a change in the magnetic field strength in that loop. You also get a current induced if you change the size of that loop. And you also get a current induced if you, say you've got this magnet near the loop, that if you change the orientation of that magnet, then you get a current induced. They also found a few things which influenced how big that change in the current was through the loop. So to make a bigger change in current, which I'm going to draw down here as an arrow, so to make the current larger, you needed to have a magnetic field strength changing quite quickly. So I'm going to write that as the rate of change of magnetic field strength is high. So the higher that rate of change of magnetic field strength, the higher the current induced. The same goes for the area. If the area is changing quickly, then the current will change quickly. And the same will apply for the angle between, well, the orientation of that magnet. And I'm going to write that just in words this time. The rate of change of magnet orientation. They also found that the rate at which this magnet is moving towards or away from the loop influenced the size of the current. So for a magnet which was moving with a very fast velocity, so this is, I'm just going to write that little v there, for a very fast velocity the current would also be increased. And also you get a larger current induced if you had multiple loops of wire. So if you had many, many loops of wire all wrapped on top of each other, then you would have an increased, a bit like a solenoid. So if you had many loops of wire, then you'd have a larger current induced there. I should just point out here that this change in magnetic field strength, I'll just indicate that here, this change in the field strength induced a current. And if you move a magnet near towards and further away from a loop of wire, you'll be getting a stronger magnetic field as it moves closer, because those field lines are closer together, and then as it moves away, you'll be getting a weaker. So, I'm just going to write here, this can be created, not created, controlled by position of magnet. And that kind of fits in with their actual observations that they were making. So now we're going to move on to something called magnetic flux, which kind of sounds like it comes from some kind of science fiction book. Not a flux capacitor from Back to the Future. Magnetic flux. And it's only after we've defined magnetic flux can we talk about Faraday's law and try and explain some of these observations.